Hello, this is Farhan Shakil from the Republic 2.0, and here we are with the part 2 of 2025, January Unit 1 exam of Edexcel Physics. So we're going to start with question number 11. You can all see the previous video in which I have discussed the multiple choices. So in the part 2 of this video, we'll start from this question number 11. The mass of the car is 1850 kilograms. Some people sit in the car. The car then accelerates at 0.230 meters per second square when the resultant force on the car is 460 newtons. So what are you going to do? You are just going to use the simple formula, which is F is equals to ma, and you have got the force, and the force is something like 460, and the mass is going to be, mass of the car, which is 1850, plus mass of the people sitting inside the car times it by the acceleration, that is 0.230. So by just sorting this thing down, you'll be having 460 divided by 0.230 equals to 1850 plus the mass of the people sitting inside the car. And over here, you would be having 2000 is equals to 1850 plus the mass of the people sitting inside the car. And you would be having 2000 minus 1850, which gives you 150 kilogram. So 150 kilogram is the mass of the people sitting inside the car. Now, if you look into it, this question number 12, a person on the sky slides down the slope. The slope is at an angle of 14 degrees to the horizontal. So what does that mean? The acceleration would be, he is moving down, but we need to calculate the component of acceleration along y, and that has to be something like g sine 14. Okay. The initial speed of the person is 7.1 meters per second square, and the resistive forces acting on the people are acting on this human is negligible. Calculate the speed of the person after moving 15 meters down the slope. So first of all, I'm just going to get myself the proper acceleration, and then I'll be using the third equation of motion to get myself the speed of the person after moving, or the final speed after 15 meters. So acceleration is going to be g sine theta, and you would be having 9.8 sine 40. And by just sorting it down, you would be having the final acceleration as 2.36 meters per second square. So once you have got acceleration, you can simply use v square equals to u square plus 2as. By plugging in the values, that we need to get the final speed, which is v square. The initial speed is 7.1 square plus 2 times acceleration, which is 2.36, and the distance covered is something like 15 meters. By just sorting this down, you would be having v square equals to 122. By taking the square root on both the sides, you would just be having v is equals to something like 11.1. So the speed of this object sliding down the inclined plane is going to be 11 meters per second. Similarly, if we talk about the question number 13 now, an escape lane can stop cars or trucks safely if the brakes stop working when moving downhill. The photograph shows an escape lane. You've got this escape lane over here. The escape lane is made of sand in the horizontal only to provide more resistive forces. The resistive forces of the sand on the vehicle reduces the kinetic energy of the vehicle. That is fine. As the truck enters the escape lane, the kinetic energy of the truck is 8 times 10 raised to the power of 6. So you've got the kinetic energy. As sand exerts an average resistive force of 3.5 times 10 raised to the power of 5 Newton on the truck as the truck comes to the rest. So what does that mean? That all the kinetic energy is being consumed to just overcome the work done by the resistive forces. So by the conservation of energy, we can keep that the kinetic energy lost is equal to work done against the resistive forces. So the kinetic energy lost is going to be 8 times 10 raised to the power of 6, and the work done has to be F times the distance covered. So 8 times 10 raised to the power of 6 divided by the force, which is 3.5 times 10 raised to the power of 5 equals to delta S. And from here onwards, I would be having the change in distance, which is going to be equal to 8 times 10 raised to the power of 6 divided by this thingy is going to give me 22.9 meters, which is the total distance covered by the truck before coming to the state of rest. So that has to be 22.9 meters. Now, you have got this B part. The resistive force exerted by the sand on the vehicle is proportional to the weight of the vehicle. Resistive force exerted by the sand on a vehicle is proportional to the weight of the vehicle. The weight of the car is less than the weight of the truck. Okay. Weight is less than the truck, right? Explain how the deceleration of a car on the escape lane would compare with the deceleration of the truck. So whenever you're talking about the deceleration, of course, the resistive forces is proportional to the weight. But whenever you're talking about the deceleration, you can easily see that the resultant force must be equal to the weight of an object. So MA comes out to be equals to mg. If A is the deceleration, what does that mean? A would be equal to mg divided by m. So when at the same time, acceleration is directly proportional to the weight, higher the weight, since truck has a higher weight, higher would be the deceleration. But at the same time, lower the mass, higher would be the deceleration as well. So what does that mean? The increase in the increase in the acceleration or the deceleration due to the weight is overcome by their masses as well. And similarly, if you're going to talk about m and g, cancel them out. So deceleration would be directly proportional to the value of g as well. So mass or weight has nothing to do with it. So what does that mean? That the deceleration, you just need to write that deceleration of truck would be equal to that of a car, right? And the main reason behind that, because the resistive force is directly proportional to the mass, is directly proportional to the mass, right? It has nothing to do with the weight. So, that is how you just need to answer this thing. Now we have got the next question, and that is question number 14. An air track on a straight tube with holes along its length. Air force through the holes lift the gliders, preventing the friction between the gliders and the air track. A teacher uses an air track and two gliders A and B to demonstrate the principle of conservation of linear momentum. Gliders A and B move towards each other and then collide, right? And we need to state that how Newton's third law applies to the gliders during the collision. So if you remember about the Newton law is just, every action got some sort of a reaction which are acting in the opposite direction. So we just need to prove that, you've got these gliders thingies. Gliders A and B move towards each other and then collide. We just need to talk about that how Newton laws applies on the gliders during the collision, right? So as A during the collision at A exerts a force on B, as the glider A is going to exert a force on B, B would also exert a force on A in opposite direction. In opposite direction, right? So A would be exerting an equal force on B and B would be exerting an equal force on A, but in the opposite direction. So you just need to explain this thing. Now, if you talk about this B part, we've got some of these two gliders, 0.15 and 0.20, and they are approaching each other with a velocity of 0.32 and 0.11 meters per second. The gliders are going to stick in the collisions, right? As they're going to collide, they are just going to stick along each other. And as they're going to stick to each other, the student predicts that the glider will move to the left after the collision. So the student is predicting that the glider would move left, right after the collision. So deduce whether the prediction is correct or not. So what are we really going to do? We just need to calculate the total momentum of both of these gliders approaching each other. And after we are done with the total momentum, we just need to talk about the final velocity of these objects, right? On this direction, it has to be, we are taking it as right. And on this direction, we're taking it as negative. So first of all, let me just calculate the total momentum. And that is the total momentum right before the collision. So 0.32 times it by 0.15. And since this glider B is moving in the left direction, so minus 0.11 times it by 0.20. And by just solving it out, you would be having the total momentum. You would be having the total momentum as equal to 0.026. 0.026. And if you calculate the final velocity from this thingy, so the total momentum before collision would be equal to the total momentum after the collision. We both know that they're going to, uh, stick together after the collision. So where they are going to move, we just need to calculate the V for it. So M1V plus M2V. So I'm just going to keep it like V times M1 plus M2, which is 0.15 plus 0.20. And by just sorting it out, I would be having 0.026 is equals to V times 0.35, and 0.026 divided by 0.35 is equals to V. So this expression is going to give me a positive velocity, right? Whatever it is going to give me a positive velocity. It is going to be 0.074 meters per second. Since it is going to give me a positive velocity, what does that mean? We at the first, but before starting this question, we assume that towards right velocity would be taken as a positive and towards left velocities would be taken as a negative, which is also a basic convention while doing such questions. And now you can see that we got velocity as positive. So what does that mean? That the glider A would be moving towards the, or both the, when glider A and glider B are going to collide with each other, they are going to move in the right direction, right? Because the velocity at the end of the day came out to be positive. So what does that mean? The student prediction was utterly wrong. Okay. Now we'll talk about this question number 15. A Cratchwan, or whatever it is, a hydroelectric power station in Scotland, is built inside a mountain. Water from the lake near the top of the mountain flows through straight pipes to a generator. The pipes have a length of 350 meters and are inclined at an angle of 55 degrees to the horizontal. So pipes are inclined at this angle. The gravitational potential energy of the in the lake is used to generate the electrical power. In 1 minute, each pipe transfers 1700 meters cube of water to the generator. The density of the water in the lake is 110 kilograms per meter cube. So if you want to calculate the power transferred, first of all, you just need to calculate the potential energy and divide it by the time taken, and you'll get the power generated. So first of all, for the potential energy, we're unaware of the mass, but we can simply use density is equals to mass upon volume. So mass has to be density times volume, where density of this thing is 1100 and the volume is 1700. So by just multiplying them up, I'll be having the mass of an object, and it comes out to be 1.87 times 10 raised to the power of 6, right? And after this thingy, I'm just going to calculate the gravitational potential energy, and that has to be the simple formula mgh 1.87 times 10 raised to the power of 6 times 9.8 times. Now you can see that the height of these pipes is not perfectly vertical. They have given you 350 meters and they have given you an angle. If you want this height, this is basically the opposite side of this 55. So if you want this side, you just need to use, for example, if I would have been using sine 55 equals to opposite, which is the height divided by the 350. So height has to be 350 times sine 55. So that is what I'm going to use over there. So over here, I would be having something like 350 times sine 55. I'm just going to work it out, and I'll have my final potential energy, and that is going to be something like 5.26 times 10 raised to the power of 9 joules. I need to calculate the power generated, and that has to be the potential energy, which is 5.26 times 10 raised to the power of 9, and I'm just going to divide it by the total time taken, and that has to be the 1 minute. So 1 minute is basically 60 seconds. By just dividing them up, 5.26 by 60, I would be having something like 87.7 times 10 raised to the power of 6 watts. So what does that mean? That I've got almost 87.7 megawatts, which was to be proven over here as well, I guess. Yeah. 88 megawatts, right? So our answer is somewhere around it. The next thing in the B part, wave travels from the lake to the generator through the four identical pipes. Four identical pipes. So what does that mean? It means that the total output power would just be 4 times 870.7, and then the power wasted at 256 watts. So the total power output has to be something like 4 times 87.7. If I'm going to calculate the input power, it would be 4 times 87.7. That is the input. And if I'm calculating the output power, it has to be the same input, but taking away the wasted power, which is 256. So 4 times 87.7 is going to give me 350.8 megawatts. And output power over here is going to give me something like 94.8 megawatts. Since I need to calculate the efficiency, so efficiency has to be 94.8 divided by 350.8 times it by 100. So by just, since we just need efficiency, we do not need to times it by 100. So by just dividing them up, you'll get the efficiency, which comes out to be 0.27, right? So that is how we're going to do this question number 15. And now we've got this question number 16. We've got the center of gravity of this hinge. We've got this dish over here. We've got the string which hangs it upwards. So in the A part, he's just asking us for the conditions needed for an object to be in equilibrium. So if you are talking about the equilibrium, remember that there are only two conditions. Resultant forces acting on the object must be equal to 0, or summation F must be equal to 0. Secondly, the resultant moment acting on the object, which we can represent like this, it also must be equal to 0. You just need to write it in theory that the resultant force should be 0, and then resultant moment should be 0 as well. Okay, now in the next part, I've been given that the dish is moved along the beam. So for example, if that was the beam, if I could just draw it, the dish was moved. Originally there was a string, and that was the center of gravity. And between the center of gravity and the string, the original distance was 8 centimeters. And originally the dish was somewhere hanging up here. And the distance between the string and the dish was something like 25 centimeters. This distance was 25 centimeters. So what we have done now, we have pulled this dish somewhere over here now. And now the distance between them is not more than 7 centimeters, right? So we have got this 7 centimeter as the final distance. Rice is added to the dish until the balance is in equilibrium. Deduce whether the dish now contains 3 portions of rice. You should include a calculation for the weight of 1 portion of rice. Weight of the beam is 3.1 newtons, and weight of the empty dish is 0.64 newtons. So first of all, I'm just going to calculate the total weight of the portions of the rice. So, first of all, just, since this moment must be acting like this, and this must be acting like this. So you need to calculate the clockwise moment and the anti-clockwise moment. So first of all, I'm just going to calculate the moment due to weight of beam. So the moment due to the weight of the beam has to be the weight of the beam times by the moment arm, and that has to be 0.08, right? For this one. So 0.8. So the weight moment due to this weight comes out to be 0.248 Newton meters. So that is how you can easily calculate this moment. And now if I just need to calculate the total distance over here, I would be having something like, if I'm talking about this thing, I've got 0.248 as total weight. It must be the same over there as over the other side as well. So 0.248 must be equal to weight of rice and dish and times it by 0.25, which was the original moment arm. So by just calculating that out, I would be having 0.248 divided by 0.25, and the weight of rice plus dish comes out to be weight of rice plus dish comes out to be 0.992. Now, since the weight of the dish was given, it was 0.64, we can actually get the weight of the rice now. So weight of the rice would be 0.992 minus 0.64, which comes out to be something like um, 0.352, right? So now by just sorting it out, we need to calculate the total portions of rice. So we can just simply use this main equation again, that the total anti-clockwise moment would be equal to the moment, the clockwise moment, and that should be portions, how much portions of rice you're going to add, and times it by 0.352, which is the weight of the one portion of rice, plus you know the plus thing is the total other thing is 0.64, which is the moment, which is the weight of the dish, and times it by the momentum which holds now 0.07. So by just sorting it out, 0.248 divided by 0.07 minus 0.64 divided by 0.352, and you'll get the portions of rice that you can add on that dish. And by solving it down, the portions of rice that you can add into it comes out to be 8.2. So it was none other than, he just deduced. So it is not 3 portion. We can have 8.2 portions of rice onto that dish, right? So that is how we're going to do this question. So that was part 2 of 2025 January physics exam. I'll get back to you guys with the part 3 of this video. Thank you very much.